All right, hey everybody, this is Scott Moore, and you're watching the SMC Journal podcast, the show that's all about performance engineering and IT today. Don't you wish there was a company that would take your Kubernetes pods and your application stack and your database and just tune all of that stuff using AI and machine learning as part of an AI ops initiative? It'd be great if there was something out there like that. And fortunately, there is, my friends at Akamas. If you check out akamas.io, you'll see that they've been doing performance optimization using AI technology for the past few years, especially around pre-production testing and staging environments. But we've got a special announcement as of today, if you're watching this the day of release, and we're going to talk about that on today's show. But before we do, let's talk about the sponsors that make this podcast possible so you can watch it. This episode is sponsored by Micro Focus and the LoadRunner Solutions family. That includes LoadRunner Professional, Enterprise, Cloud, and Developer. You know, performance matters. Did you know that LoadRunner Solutions have the largest community of practitioners in the world? Join that community at community.microfocus.com, scan the QR code, and check out the LoadRunner family page on performance engineering, as well as their YouTube playlist that we've got links for in the show notes on smcjournal.com as well as YouTube. This episode is sponsored by Performance Lab. They're a provider of premier load and performance testing services for enterprises in all industries. They focus on a robust methodology, tools, and the experienced engineers that know what they're doing. Since 2008, they have built a reputation for reliability worldwide. BoomQ is their own innovative performance testing platform. However, they also consult around many industry standard load testing tools like JMeter, LoadRunner, and others. Find out more at performancelabus.com. This episode is sponsored by Supervisor. Stop losing money with a slow website. With Supervisor, you can continuously track the performance of your code and your hosting. Predict site page load speed with high user volumes and an easy one-click load test solution. Find out more at supervisor.com. Okay, so using AI and machine learning to tune your applications, your Kubernetes deployed applications, your standard deployed applications, Java, Node, Golang, you name it. Well, that's what Akamas does, and they've been doing it for quite some time. But they have a major announcement today on this show, and to bring that to you, I decided let's bring the CTO, Stefano Doni, on the show and let him talk directly to the audience about what it is and what it means for the product. Let's go there now. Hey, Stefano, how are you?
I'm great, thanks.
Would you reintroduce yourself and your company, Akamas, for those who aren't familiar? What does Akamas do?
Sure, Scott, thanks for having me today. Well, I'm Stefano Doni, CTO and co-founder of Akamas. At Akamas, we are creating a platform which uses AI to automatically optimize application performance, reduce costs, increase resiliency at the business speed.
Okay, so you're using AI and machine learning to basically do performance tuning and do it faster and hopefully better than just humans alone can do that. And is this only for Kubernetes or is it for anything?
Yeah, Akamas is a platform, it's a flexible platform that can optimize any technology. So being a Kubernetes, run Java applications, it could be databases, big data, etc.
Okay, so I've been knowing you and about this product since the very first release. I think we met in 2020, early 2020, in Vegas at the CMG Impact show when you were basically announcing version 1. So there's some big news today that we want to talk about. What's that big news?
Yeah, today we are very thrilled to announce that we are releasing the version 3 of our Akamas platform. That brings major product development. In particular, that brings the ability to optimize application directly in production.
Okay, so before now, you could only apply your solution, or should be only applying your solution to test environments, staging environments, pre-production environments, right?
Yeah, that's right. That's where we started a couple of years ago. So our use case was really helping performance engineers as a persona to actually optimize application performance, resiliency in pre-prod environments, staging, like you mentioned. There are still several good use cases to that, of course, today, like, for example, making sure my application is optimized to sustain, I don't know, additional load due to a Black Friday campaign, or make sure the configuration of the application infrastructure are optimized with respect to also chaos engineering, chaos failure scenarios. So there are still a lot of valid use cases to apply production, pre-prod environments optimization, of course. But today we are announcing kind of the next step. So being able also to optimize once I'm releasing my application in production, how do I make sure that it's constantly being optimized when real life workloads come in? And that's actually kind of the major thing that we are announcing.
I could see where when somebody hears we're applying AI to tune my production environment, anything that touches my production environment can be very sensitive for people. So, how does this live optimization work?
Yeah, that's a great question. So first of all, let me say that since the beginning, when we founded the company in 2019, actually our vision was really to being able to help solve customer jobs on delivering services faster with better performance, resiliency, lowest cost, which means, of course, taking care of what happens also when application run in production. So actually, to come to your back to your question, so the idea is that we move from a phase where when we optimize application in pre-prod environment staging, actually Akamas does a kind of different approach. So it's a kind of experimental based, meaning that, of course, being in pre-prod environments, we don't have real users hitting the application. So we are more free in a way to do experiments, change a lot of parameters, kind of while they doing experiments. And that's great because actually Akamas in this way, you can literally explore all the configuration options and find out really the best configuration for your specific application and workload. But of course, when we move to production, actually, another kind of requirements are actually arising, like, of course, safety. So I don't want to have control of what kind of changes actually my Akamas is suggesting to my application. So that kind of led us to radically change also our AI approach, which now becomes much more observe and recommend. Observe means that Akamas now observe what is happening in production. So we have integration with observability tools to understand, for example, how is the application behaving today, what is the workload. So Akamas is now able to understand what is the actual workload and understand workload context. So for example, you have a peak, what's the performance under your peak, what is the best configuration that now can support your peak, etc. So we observe what is the application and how that is behaving under production workloads, and then we recommend. So that's kind of recommendation step where actually the human is in the loop. So we have performance engineers, or more typically SREs and DevOps team. That's kind of more our target user with production, with live optimization, as we call them, because people typically want to have control, want to see what is the best configuration that Akamas is recommending, and they want to be able to apply that. They want to be able even to review and revise possibly before actually updating it and rolling it out in production. So we went from a more experimental approach to a more observe and recommend approach.
Okay, so you've got these experiments that's been happening in pre-production. Now you've got observations, and it's based on what you've been learning. I'm assuming that over these past several version upgrades and updates that you've been making, you've been applying information that you've been learning from clients that have been using it. You've been building rules and you've been building out the knowledge base, I guess, for this application to know what's best for Java-based applications or Golang or Node or something like that. So are you taking that, I'm using the word knowledge base for lack of a better term, but are you taking all of that information and then utilizing that as like best practices for these observations that you're recommending? You're not having to make the change, you're going by what you see and based upon what you already know. Is that how it works?
Yeah, that's a great summary, Scott, because actually our approach is full stack. I guess we are going to mention it. So it's important not just to optimize the infrastructure, like in Kubernetes, the container, CPU and memory requests and limits, but also go deeper within the container. So what is important is what runs within the container to really unlock the the cost efficiency and performance and reliability kind of puzzle. So that where we learn a lot about what works, what doesn't work, both from a technology perspective. So what are the most important tunables, parameters that we must still tune in production environments. But then the other piece is that we needed to radically enhance our AI algorithms that now must, for example, take safety much more into account. So being able to recommend a configuration that is that makes sure that we are not doing, in a way, wrong things in production. So that we have several policies, safety policies that we introduced, so that the people can have the control and that in a way, the trust of actually deploying in production the recommendation that Akamas is providing to them.
So one word that keeps popping up, I'm actually going to be talking about it a lot. Even I'm doing an interview in a few weeks about this on the Performance Tour on the term AI ops, which is taking AI and the associated capabilities of AI and machine learning and applying it to operations. Things like observability platforms is mostly where we're here. But this, to me, this is also AI ops, especially now that you're moving into production. So there are a lot of companies right now that are trying to capitalize on this and say, okay, we're going to help you use AI to better observe, better visualize, better, in this case, optimize your application. So what is the differentiator for Akamas? How are you different from anybody else trying to use AI ops?
Yeah, great point, Scott. So AI ops is pretty big umbrella. So we have actually several differentiators. So by the way, we will be releasing a white paper on that on live optimization on our website. Basically, it comes down to two big topics. So one is being able to be goal driven. Specifically, Akamas optimization goal might be, for example, performance oriented or application performance oriented. So application performance for us is key. So it's not just a matter of let's bring down the cost, but it's important in the cost efficiency picture to make sure that we are not making the application runs lower. So application performance is directly considered by AI during this optimization. So that's very different from all the solutions out there that just work at the infrastructure level. Like, I don't know, I am using 10% of my CPUs. I can just reduce my CPU limits or requests and everything will be fine. That might not be true because actually, due to the complexity of those environments, actually that might not be true. So it's always important to measure application performance. So that's one differentiator. By the way, application performance can even become a goal. So a goal for Akamas Live might be, let's bring down my response time. So that's something that is very, very important. How do I tune my stack to make sure that my Kubernetes microservices run with the highest possible performance? So that's key, and where also my SLOs can come into the picture. So that's one differentiator. The other one is being able to be full stack. So especially in Kubernetes, what we mean by that is being able not just to optimize the infrastructure, meaning that, for example, the sizing of my pod of the container more properly, but also considering what runs within the container. So for us and our experience, what we learned working in the customer is that literally the two layers are deeply interconnected. So you cannot really solve the puzzle of improving performance, keeping high reliability and lower cost without taking into consideration what runs within the container. That's key because, again, solutions that simply look at the infrastructure metrics are going to miss optimization opportunities, but also are going to risk introducing opportunity for failures like out of memory if you don't know, for example, consider properly the JVM memory allocation that runs within the container or the Golang runtime, etc. So that's kind of key for us.
So if I understand what you're saying here, talking about full stack, if you are saying, if you're a vendor that's saying we provide performance tuning of Kubernetes deployed environments and we can automate that with rule sets, but you're only looking at the infrastructure component, that would be akin to traditional applications that have bare metal servers and saying, okay, we're just going to put a terabyte of RAM in this machine, but the performance problem has nothing to do with the amount of RAM that's being used. It's something else that's running on it that's just a dog. Like you're talking about, the JVM and the garbage collection is what's actually going to get you. And you can keep throwing stuff at this, but then at that point, it's not efficient at all, and you're spending more money on the infrastructure. So that's kind of akin to this. It's like you can't just look at CPU and memory and this. You have to consider what could be slow from the code layer, from other libraries, for example. Is that what I'm hearing?
Yeah, that's a great analogy, actually. So the thing is that what people actually sometimes miss is that what literally drives the consumption of my container. Let's say I want to bring down my Kubernetes cost. That ultimately comes down to how many resources my container is consuming, right? CPU and memory. What is key to understand is that most of the time, what is really driving the consumption of those resources is what runs within the containers, especially it's not simply due to application code. That is, of course, true. If my algorithm is inefficient, I will consume more memory, for example. But ultimately, what the key layer that drives the decision of how much memory, for example, to allocate is really literally the runtime. So it's typically the JVM for Java languages, but there's pretty much any modern language today suffer the same issues like Golang or Node.js. They are all garbage collector runtimes. So for example, the runtimes literally does the decision of how much memory do I allocate, for example. And that is, for example, we keep hearing from teams that allocate, for example, 4 gig of RAM to my JVM. That means that, as we know from experience, the JVM really consume memory depending on the configuration, not just about with respect to the demand that is driven by the code and the traffic, but literally how do you configure the JVM plays a key role in terms of resource consumption. So let's say that your JVM is configured with 4 gigabyte of RIP. Literally, if you just right size the container, you literally cannot go below 4 gig because that's the current usage. Really, you cannot really shrink that. But if you look at the configuration, you can, for example, understand that your 4 gig can quite become, for example, 2 gig of RIP, and the application performance will still be okay or acceptable based on your SLO. So literally, you may be wasting a lot of money because simply developers do not know how to configure the JVM. That's the common thing that we see, and hence solutions just look at the container level, as you mentioned. Just like in the physical world, you are kind of throwing money at the problem, and you see it can have performance problem because of the issue that you might have.
This is something that we talked about on the Performance Tour Roadshow when we talk about AI and we talk about how to use AI to performance tune something. In that the companies that come up with the most rule sets and their own knowledge base of these rule sets that will help guide people through best optimization, best practices around that, those are going to be the leaders in the industry for this moving forward. And you've built quite a library of different technologies. Can you just mention a couple of the things that's beyond Kubernetes that you have specific packs for that people could use to optimize certain technologies in the stack?
Yeah, sure. Other interesting use cases are cloud instances, for example. How do I determine the best cloud instances out of the hundreds that AWS, for example, provides? Other use cases are big data, like Spark systems. Again, more than 100 parameters for each Spark application. Or, for example, databases. We work a lot, for example, on MongoDB, Postgres, etc. So pretty much the full stack powering modern application is kind of full of knobs that you have the ability to tune.
Okay, so we talked all about this, but I want to show this graphic right now just for people to visualize this and why this is such a big deal. If you take the left-hand side of test and pre-production, we've got all of these benefits, I guess, across the top where we're improving service quality, increasing business agility, increasing service resilience, reducing the cost, which is the biggest deal I think most people are talking about right now, then optimizing your cloud migration. All those benefits then now become part of the right-hand side, the production side, right? And so what we're saying is this is what Akamas is defining as AI-powered autonomous optimization. Is that right?
Yeah, that's right, Scott.
And is there anything that we need to add to this bottom piece where we talk about it's continuous, human approved, and fully autonomous? So when I hear human approved and fully autonomous, that seems like that's a discrepancy. Why is that not different?
Yeah, that's a great question. It comes down to the level of control the people require actually when you are moving to production optimization. So actually, the typical the first approach would be literally to have recommendations, and then that human needs to approve before actually being rolled out to production, as we mentioned. So that gives the ability to actually review the parameters, review the settings, what Akamas is recommending, making sure that they they can trust it, and then they can approve it. So that's kind of the typical process that we see with initial adoption by DevOps teams and SREs. But when you actually acquire the trust, you can put the Akamas in a kind of autopilot mode. So by fully autonomous, we mean that we can actually configure your live optimization to be to not require actually any manual approval. So as soon as Akamas will come up with a new recommendation, by the way, we have plenty of way to specify the frequency, etc. That recommendation might trigger a deployment to production. By the way, we can do that either by directly talking with the Kubernetes cluster, or more typically also integrating with kind of more modern GitOps approaches, where Akamas won't touch the cluster, but Akamas will simply update your configuration repository where all your microservice configuration are stored, and then your pipelines will take care of actually deploying the application in production.
Well, this is a mouthful, okay? Full stack, continuous, AI powered, autonomous optimization. If you really describe what this is all about, that's really what we're talking about. And I think maybe the shortcut to that is just let us make your applications better. Just let us help you take care of it, make it better and more efficient and performant, and all the things that you like, right? Let us do that for you and help you. That's what it sounds like to me. Is there anything else you wanted to mention or talk about? Because this is a big release for you.
That's true. That's true. The other thing that it's worth mentioning, I guess, it's that the runtime, the full stack piece is important. Also, not only for cost reduction reasons. So we see a lot of customers literally struggling, especially on Java workloads, to understand how to properly optimize what the JVM within containers. So literally, that's one of the most common themes we hear from customers. And even the runtime itself, that is due to the runtime itself not literally being designed to run within containers. By the way, it's not just Java. So even Golang recently introduced a new memory management mechanism, and garbage collection changes that still resemble quite a lot what is being done in the JVM. V8, other runtimes are the same. So the JVM are configuring themselves to actually understand what runs with what is the container size, but that can lead to lots of surprises. So that's an important piece, because that can trigger also a lot of performance issues on Kubernetes due to throttling, etc. If I don't know, the garbage collection is not properly configured. So not just about cost, also performance, but what we are also seeing is about reliability. So a lot of teams that we see are struggling with out of memory errors in production. So Kubernetes literally killing your containers, and then cannot figure out why. So oftentimes we have developers that simply, think the culprit might be the code. It might be a memory leak. But in the end of the day, the real problem is that they wrongly configure a JVM to run within the container. So considering the way that JVMs use memory, or Golang use memory, you are going to be hit quite hard, and you are in for a lot of surprises if the two layers are not actually considered together.
We don't want any surprises in IT. That's bad news for everybody. Stefano,
Exactly.
thank you for being on the show today, and thank you for announcing this. This update is available as of today when this podcast comes out on the 13th of September, 2022. So if somebody wants to find out more information, where should they go, and what should they be reading up on to find out more?
Yeah, just head over to our website, akamas.io. You will find here the new white paper about live optimization that you can download. We went pretty deeply to describe the product, so if you are interested, that should be a nice resource. And I also want to mention that we will be heading to KubeCon in Detroit in October. So exactly. So we are very, very pleased to be there and meet finally also be there on the floor and meet lot of people. So that would be another great way to reach out to us, and we would love to talk to you and hear your challenges also about Kubernetes optimization.
Well, guess what? I think I'm going to go to KubeCon with you. How about that?
Yeah,
So, for those of you who are going to that conference in Detroit, I'll be hanging out with Akamas, and we'll be talking about all this stuff a little more detail. That's at the end of October, but definitely check it out. That's available on their website, and it's akamas.io. We'll share all those links on the show notes as well. So, thank you again for being on the show today. We appreciate it.
thank you, Scott, for having me. Have a great day.
So what do you think about this? Full stack tuning, autonomous optimization. Are we going to finally get to the point where we can trust AI to make changes in production from things that it already knows, the learning that's already been done in pre-production environments, and applying those best practices? Can we eventually take our hands off of the wheel and let this thing drive for us, and knowing that it will make it efficient, make it performant, and it will cover all the bases that we may miss as humans. I don't know. What do you think? I'd like to hear your feedback on that. I'm easy to reach. If you go to my website, scottmoore.consulting, you can also reach out to me through social media. There's a link to my Twitter profile at LoadTester or LinkedIn as well. I'm pretty active on there. You can also just send me an email quickly at help@scottmoore.consulting. I'd really like to know what you think about this announcement. And do you think it's as much of a big deal as I'm making on this show? If you don't, I'd like to know that too. If you like the kind of content that you're seeing on our YouTube channel, hey, how about subscribing and clicking that little bell so you'll be notified when we produce new content, which comes out, by the way, every week, twice a week, Tuesdays and Thursdays at 8 a.m. Eastern Time. So until the next SMC Journal podcast, this is Scott Moore saying thank you again for watching, and bye-bye.